In this video, we'll do a more thorough dive into some of the things that we can see in SPSS regarding doing a linear regression where we have two quantitative variables and we're fitting a line. First, let's just look at a graph again of a scatter plot between two of the variables. What we're going to do is go to scatter dot and then simple scatter and then define. Our x variable we will look at is height, and we will see if that helps us predict shoe size. And we click OK, and we will look at the scatter plot. We can see we do have a linear relationship. To check those conditions we talked about, that was number 1. We don't have any crazy outliers going on, which was number 4. And the variability we're seeing if we just look across here and across here is pretty constant from left to right, so no issues with that either. Then to fit the linear model, we go to Analyze, Regression, and then Linear. We will put in our dependent variable, again, as shoe size, and then we will put height as our independent variable, and click OK. Then when we look at our output, we have a correlation of 0.883, that is our R. We talked about that earlier in the course. Our R squared, our coefficient of determination, is 0.78, and we can get that because we fit a line by taking 0.883 and squaring it. Another number we talked about was our S sub epsilon, the standard deviation of the error. That is listed here as the standard error of the estimate, which is 0.9353. We've also looked at the ANOVA structure for regression. We have our sums of squares regression of 197.917. If we would divide that by our total, then what we would get is that R squared. Remember, that is the percentage of variation that is explained, so it's the regression of sums of squares over total sums of squares. Then this F statistic, test statistic of 226.27 with a p-value of essentially 0 is for testing if the model was effective or not, and so we can see with a small p-value we do say that a linear model is effective. In our coefficients box under B is our slope and intercept, so we have our line of negative 17.626 plus 0.398 times x. The standard error of the slope is the 0.026 listed right here, and when we divide our slope divided by standard error, we get our t-test statistic of 15.042 with, again, essentially a p-value of 0, saying that we do expect to see a linear relationship in the whole population. Now, if we wanted to check if our residuals look normal, which was our last condition, what we actually need to do when we run this model, if I go back to Analyze, Regression, and Linear, is we need to save our residuals. So when we put these variables in, we can, before we click OK, also click the Save button. And under residuals, we can click on Standardize. That will rerun everything, but when it does that, one extra thing that will happen is if we look back at our data set and we scroll all the way to the end, we'll see that this new variable here has been added, which is our residuals. Now that those are in our data set, we can plot them. So if we want something like a histogram, we can go to Graphs and then Histogram, and then put our variable of the unstandardized residuals in and click OK, and we will get that histogram, which is a little bit skewed here, so we'd probably not trust that that actually looks normal for this case.